Imagine standing inside a billion-dollar masterpiece, a structure designed to be the crown jewel of modern civilization. Everything looks perfect from the outside. The steel is polished, the concrete is set, and the world is watching. But inside, it's a death trap. As the sun rises over the Arabian desert, the temperature inside the half-finished Burj Khalifa begins to climb. It doesn't stop at 80 degrees. It doesn't stop at 90. By mid-afternoon, the interior is a staggering 100 degrees Celsius. That's the boiling point of water. The engineers didn't see it coming. They had focused so much on the impossible task of building high, they forgot about the physics of the sun. The window panels, meant to be the building's skin, had turned the world's tallest structure into a giant vertical oven. It was a crisis that threatened to shut down the entire project. For 18 agonizing months, construction ground to a halt. $1.5 billion was on the line, and the dream of Dubai was literally melting from the inside out. How do you fix a mistake that's 800 meters in the air? How do you build something that defies every rule of architecture on a foundation that shouldn't even exist? Today, we go behind the glass. This isn't just a story about a building. This is a story about a 6-year war against nature, physics, and the limits of human ambition. In the early 2000s, Dubai had a vision. They wanted to move away from an oil-based economy and become the tourism capital of the world. To do that, they needed an icon, not just a tall building, but the building. Something so massive it would make the Empire State Building look like a toy. They called in the best engineers, the most daring architects, and a literal army of 12,000 workers. But there was a catch, a massive one. The government gave the engineers team exactly 6 years to finish the project. Now, in the world of mega construction, 6 years is nothing. Usually, a project of this scale would take 3 years, just for the design phase alone. If the engineers spent 3 years drawing blueprints, they'd only have 3 years left to actually build it. And you can't build the world's tallest tower in 3 years. It's physically impossible. So, they did something absolutely insane. In February of 2004, they started digging. They didn't have a finished design. They didn't have the final height confirmed. They didn't even know exactly how the top half would look. They just started. It was the ultimate build the plane while you're flying it scenario. But as the shovels hit the dirt, they hit their first impossible hurdle, and it was right beneath their feet. When you build a skyscraper, you usually look for bedrock. You want a solid, ancient piece of stone, deep in the earth to anchor your weight. But Dubai isn't built on stone. It's built on sand and weak, crumbling calcarenite. The engineers looked at the soil reports and realized they had a nightmare on their hands. The ground was too soft. If they just poured a concrete slab and started building, the weight of the Burj Khalifa, hundreds of thousands of tons, would simply cause the building to sink or tilt. The question echoed through the site office. Can the tallest building in history actually stand on sand? The solution wasn't to find harder ground, but to use the power of friction. They decided to use a system of 192 solid steel piles. These weren't just poles, they were massive anchors driven 50 meters deep into the earth. They didn't rely on the piles hitting a floor of rock. Instead, they relied on the skin friction between the piles and the soil. Think of it like pushing a needle into a piece of foam. The foam grips the needle from all sides, holding it in place through sheer surface tension. The weight of the entire tower, every piece of glass, every bag of concrete, every person who would ever step inside, had to be distributed perfectly across those 192 piles. If the distribution was off by even a fraction of a percent, the tower could lean. And at 800 meters, a tiny lean at the bottom becomes a catastrophe at the top. The foundation was set. Now, they just had to figure out how to keep a building that tall from being knocked over by the wind. The higher you go, the more the wind becomes your enemy. At the top of the Burj Khalifa, the wind doesn't just blow, it screams. It can reach speeds comparable to a Category 1 hurricane. If the building was a giant rectangle, the wind would hit it like a wall, creating massive swirls of air called vortices that could literally shake the building apart. To solve this, the architects at SOM in Chicago looked toward nature. They looked at the Hymenocalyx, a desert flower with long, slender petals. They designed a buttressed core. Imagine a central hub with 3 wings extending outward. This Y shape isn't just for aesthetics. As the building rises, each wing retreats upward in a spiraling pattern. This confuses the wind. Instead of hitting a flat surface and creating a massive force, the wind is broken up and diverted. But even with a perfect design, they had to build it, and that meant moving materials to heights where the air starts to get thin. The team faced a logistical nightmare. They needed concrete, a lot of concrete. In total, the concrete used in the Burj Khalifa weighs as much as 100,000 elephants. But how do you get liquid stone to the top of a half-mile-high tower before it hardens in the pipes? The problem with concrete is that it's heavy, and it's on a clock. The moment you mix it, The countdown to it turning into a solid block begins. In the heat of the Dubai sun, that clock ticks even faster. The construction team realized that traditional cranes and buckets wouldn't work. It was too slow. They needed to pump the concrete directly from the ground to the top floors. But no pump in history had ever pushed liquid concrete that high. The pressure required was immense, enough to burst standard pipes like they were made of paper. To pull this off, they brought in 3 of the most powerful pumps ever built. They installed thick, heavy-duty steel pipes running from the base all the way to the clouds. They could only pump at night, when the air was cooler, to prevent the concrete from setting prematurely inside the pipes. It was a high-stakes race against the sunrise. Every night, the pumps would roar to life, pushing tons of liquid stone upward against the relentless pull of gravity. By the time they reached the 140th floor, they had broken every world record for pumping. But as the building grew, a new fear began to settle in among the crew, a fear that no amount of engineering could solve. As the tower crossed the 700-meter mark, the logistics changed. The massive cranes used to lift steel and glass were now operating in a realm where clouds passed below the operators. The cranes were anchored to the side of the building itself. As the building grew, the cranes had to jump to higher levels. It was a terrifying dance of heavy machinery, suspended over an abyss. But then, the project hit a human wall. The veteran crane operators, men who had spent their lives building skyscrapers, started to quit. The height was simply too much. Looking down from a swaying cabin 700 meters in the air, where the wind makes the entire structure hum, it breaks a person. The HR teams had to scour the globe to find a specific breed of human. They needed operators who didn't just tolerate heights, but who felt at home in the sky. They found men who would stay in their cabins for 12-hour shifts, sometimes even sleeping in the clouds because the trip down took too long. One operator became a legend on site. It was said he didn't just work in the crane, he lived there. For him, the world below, the traffic, the heat, the noise, didn't exist. He was a citizen of the sky, and without men like him, the Burj would have remained a stump. But even with the structure rising, that original disaster, the 100-degree heat, was still looming over them. The project was at a standstill. The interior of the Burj Khalifa was, quite literally, too hot to handle. 18 months. That's how long the construction team sat in limbo because of the glass crisis. They had built the tallest skeleton in human history, but they couldn't figure out how to give it a skin that wouldn't kill everyone inside. Normal glass was a no-go. It would act like a magnifying glass, trapping the desert heat and turning the luxury apartments into furnaces. They needed something that had never been mass-produced on this scale. Enter John Zarafa. Zarafa was the engineering mind who proposed a radical, albeit incredibly expensive solution. He developed a high-tech, silver-coated glass designed to do 2 things: let the light in, but bounce the heat back into the atmosphere. This glass was engineered to reflect the brutal ultraviolet rays of the Arabian sun, while maintaining a crystal-clear view of the horizon. But there was a catch. This wasn't off-the-shelf material. Each individual panel cost about $2,000. And they didn't need a few hundred. They needed 24,000 of them. The bill for the glass alone was astronomical, totaling over $3.5 billion in manufacturing and logistics. To get it done, they had to build an entire factory dedicated solely to producing these specific panels. Once the factory was running, the pace was relentless. The team managed to install all 24,000 panels in just 4 months. Suddenly, the Burj Khalifa wasn't just a skeleton anymore. It was a shimmering, silver needle reflecting the soul of Dubai. But as they neared the finish line, they realized they had one final, impossible task. They had reached the top, but the top wasn't finished. You see it from 100 kilometers away, the spire, that thin, elegant needle that pierces the clouds and makes the Burj Khalifa the undisputed king of the skyline. But getting that spire into place was a feat that almost broke the engineering team. The spire is a solid steel rod, 136 meters long. That's longer than a football field, and it weighs 350 tons. In the world of construction, 350 tons isn't just heavy, it's an anchor. And at 800 meters in the air, there is no crane on the planet that can lift that kind of weight. The air is too thin, the wind is too strong, and the physics of the leverage just don't work. If they couldn't get the spire up, the building would be incomplete. It would be a masterpiece without a crown. So, the engineers went back to the drawing board and came up with a Trojan horse strategy. If they couldn't lift the spire from the outside, they would build it from the inside. They transported the spire to the top floors in small, manageable pieces. Then, in the cramped, narrow heights of the upper floors, they began to weld it together. Once the massive steel rod was assembled, They used a series of specialized hydraulic jacks to slowly, inch by inch, push the spire up through the center of the building. It was like the building was giving birth to its own peak. On the day the spire finally locked into place, the Burj Khalifa officially became the tallest man-made structure ever built. But even then, there was one more problem, and this one was personal. After 6 years of construction, the Burj Khalifa was finally standing, but it didn't look like a diamond. It looked like a mess. Years of desert sandstorms, construction dust, and concrete splatter had coated those 24,000 expensive glass panels in a thick layer of grime. The shimmering icon of the future looked like an abandoned relic. The solution? There was no high-tech robot. There was no automated washing system that could handle the wind and the curves of the building. It came down to human beings. A specialized team of window washers was hired to do the most terrifying job on Earth. Suspended by nothing but high-strength ropes and harnesses, these workers lowered themselves from the top of the tower, bucket and squeegee in hand. They had to clean every single one of those 24,000 windows by hand. Imagine hanging 800 meters in the air, with the wind whipping at your back, trying to get a streak-free shine on a window. It's a task that continues to this day. It takes a team of 36 people, nearly 4 months to clean the entire building from top to bottom. And the moment they finish, they have to start all over again. When you look at the Burj Khalifa today, it's easy to see it as just a building, a tourist destination, a place for expensive dinners and Instagram photos. But look closer. This is a structure that is 3 times the height of the Eiffel Tower. It's a place where the elevators move faster than almost any other on the planet, whisking you to the clouds in seconds. It's a place where you can watch the sunset twice in one day, once from the ground floor and again by taking the elevator to the top. It's a place where the wind is so strong at the summit that the building is designed to sway up to 1.5 meters just to stay standing. The Burj Khalifa wasn't built because it was easy. It was built because a group of people decided that impossible was just a word used by people who had given up. They built on sand. They fought the sun. They conquered the wind. They turned a desert floor into the highest point on Earth. We often think of the horizon as the limit of where we can go, but the Burj Khalifa is a reminder that the horizon isn't just a horizontal line. Sometimes the horizon is straight up. It makes you wonder, what else are we calling impossible today that will be the skyline of tomorrow? The engineers didn't have all the answers when they started digging in the sand. They just had the courage to start. And maybe that's the real lesson here. You don't need to see the top of the mountain to start climbing. You just need to be willing to face the heat. If this story of human grit and gravity-defying engineering moved you, stick around. There are so many more impossible stories waiting to be told. What's the one thing in your life that feels like building a tower on sand? Drop a comment below. Let's talk about the impossible. And if you want to see where we go next, hit that subscribe button and stay curious. Because the view from the top, it's always better when you know what it took to get there.